Alright guys, so I just want to quickly go over the quiz that you guys took before winter break. So let's jump right in. I'm also going to kind of walk you guys through on how I graded this quiz, and then I'm also going to print off kind of like a checklist on how this quiz was graded, because it would be very similar to our post test that we'll take. So ignore number 1. Number 2 says, write an equation in standard form. So standard form is going to be ax plus by is equal to c. Now, I had a couple students that just left it right there. I'm okay with that. But really, though, when you're making up your own, you can literally write any number you want. The only rule is that something like that. The only rule is that the coefficient of x has to be positive, and it has to be a whole number. Okay, so something like that. That's going to be 3 points. I gave you guys 3 points for 1, 2, 3. A, B, and C. Writing equations in slope-intercept form. I also had a couple students that took their standard form and solved for y, and then left it in slope-intercept form. So if I'm solving this for y, so the first thing that happens to it is it gets added by multiplied by 2. So I'm just going to quickly show you how I would undo this. Here's y. Gets multiplied by 2, increased by 3x. The result is 4. So the first thing I need to do to both sides is subtract 3x and then divide by 2. So I can go subtract 3x from both sides. So now I have 2y is equal to 4 minus 3x. Divide that by 2. Both sides by 2. You get y is equal to 2 negative 3 halves x, and there is your slope-intercept form, plus 3. For that one though, some of you just wrote something like y is equal to some y-intercept, some number, and then some rate of change, some slope. That's fine too. Okay, 3 points. 1 for y by itself, 1 for the y-intercept, and then 1 for the slope. Okay. Number 4, solve the following systems of equations using the substitution method. So this one, since I have y is equal to, I know it is a system because it says this is a system. But when you have two equations that is already solved for one of the variables, y is equal to or x is equal to, okay, you can simply just do something like this. Y is equal to negative 2x minus 3. Since this is equal to y and this is already equal to y, both of these are y's. And they're part of the same system. So I know for a fact that they are the same rational number. So therefore y is equal to y. Because they are part of the same system. In this case, if I wanted to, x is equal to x because they're the same x. There's only one x or one y value that would satisfy this one if you're solving for a solution point. Now, if you get something like, all your variables disappear, that's no solutions. Okay, so or if you get x is equal to x, then you know that it's going y is equal to y, something like this. You just simply substitute it in there. So since the first one is y is equal to negative 2x minus 3, I'm just going to write that. Because that is the same thing as y. I just said it over here. The second y is equal to negative 1/4 x plus 4. And here I simply I got rid of my y's. All I have left is x. I have negative 2x on one side and then negative 1/4 x on the other side. So my goal is to get all my x's on one side and all my constants on the other side, and then simply do some undoing, solving, and get x by itself. So let's just jump right in. I'm going to go ahead and add 1/4 x over here. That's gone. Draw my line, drop everything down that didn't get canceled out. Here we have negative 2x plus 1/4 is going to be negative 1 3/4 x. Now some of you kind of got confused here at this step. When I'm going to go up here. When you have negative 1 3/4 x minus 3 is equal to 4. You add 3 to both sides. Negative 1 3/4 x is equal to 7. You divide both sides by negative 1 3/4. And this is a step where some of you got tripped up, this math right here. Now, if you're going to do negative 1 3/4 in the calculator, make sure that you put this whole thing in parentheses. Okay, so on a calculator, it's going to say something like, you would do negative 1 plus 3 divided by 4, close parentheses. And that will give you something like, you actually have to use the division symbol on the calculator. But why risk it? Here, I'm hoping that you guys understand that numbers can be changed from one form to the other, and they don't change. Here, I would simply just change this to negative 1.75. That would have been way quicker, way more efficient. Same thing with the original problem. If you see negative 1/4, go ahead and change that to negative 0.25, negative 25 hundredths. See if you can simplify or change something so it makes it more manageable before you start jumping right in and solving it. Okay, so now I have, going back to the problem, running out of room here, I have 7 divided by negative 1.75. Okay, is equal to x, because this side already canceled out. X is going to be equal to negative 4. Some of you, stop right there. Be careful. You're finding a systems of equations. So you found one coordinate, you need to find the second one that's satisfied. Now we just need to find y. After you did the substitution method and you got x is equal to negative 4, so you simply take you take your negative 4 and you put it back into the original system. Okay, so I have y is equal to negative 2x minus 3, or y is equal to negative 1/4 x plus 4. I'm going to go ahead and choose A because there's no fractions in there. I'm going to go ahead and put in y is equal to negative 2 times negative 4 minus 3. Some of you actually got 11 for y because you only did it for one. You didn't check the second one. Be careful. Your signs matter here. Y is equal to negative 2 times negative 4 is positive 8 minus 3. Y is equal to 5. So my solution point is going to be negative 4, 5. This is when I would take that extra step and I would check it with equation B. Make sure that it works. Y is 5, so 5 is equal to negative 1/4 times negative 4 plus 4. And I hope that that equals 5, because negative 1/4 of negative 4, negative times negative, that is going to be 1 plus 4. 5 is equal to 5. So this works for both, and that's the substitution method. Okay. This one right here, it says graph the inequality 4x minus 2y is less than or equal to 14. There's a couple of different ways to do this one. This is already in standard form. I know it's going to be a solid line. Okay, so you can actually find just the x and y intercepts, plot those, connect them, or you can change it into y, solve for y is equal to, and find the y-intercept and the slope. A lot of you do it that way, so I'm going to go ahead and do it that way. So I have 4x minus 2y is less than or equal to 14. I know that this 4x is positive because there's no negative sign in front of it. So in order to move this to the other side, I got to subtract 4x. Subtract 4x. Bring this down. Some of you forgot the negative symbol. I have negative 2y is less than or equal to 14 minus 4x. To undo this, I would divide both sides by negative 2. Negative 2 divided by negative 2 is positive 1y. Mirror rule here. A lot of you forgot the mirror rule. When I divide or multiply an inequality statement by a negative number or an integer, I got to flip the sign. 14 divided by negative 2 is negative 7. Negative 4x divided by negative 2 is positive 2x. Okay, I'm going to take a moment and kind of explain that real quick. If you have y is greater than or equal to 14 minus 4x divided by 2, earlier you saw me write something like this. I wrote something like, hey, 14 over negative 2, sorry, that should have been negative 2, minus 4x over negative 2. These two are the same because these are called rational numbers. My denominator here, how do you subtract fractions? You keep the basis or the denominator the same. So really, you can actually just break it up into its own little chunk like that. You would do 14 divided by negative 2, and then negative 4x divided by negative 2. Okay? So here, I have my y-intercept is negative 7. 0, negative 7. My slope is 2, so go up 2 over 2, up 2 over 2, and I know that it is a positive 2 because negative 4x divided by negative 2 is positive 2. Since it is a less than or equal sign up here, we flipped it down here, it doesn't change the fact that it still has that equal, so it's going to be a solid line. Something like that. So you would get 3 points for this. Okay. Well, you would get 1 point for showing me some type of intercepts. I can see where you start. I can see your slope. That's 2 points. Another point would be, the solid line is 1 point. And then showing me that you could see the slope is the second point. And the third point is the shading, because you got to graph this. This no longer is true because I manipulate it to here. Those two are exactly the same. Since this is y is greater than or equal to, that means all my y values that I put in here have to be larger or equal to this entire statement. Well, you can start with 0 for x, right? You can do 1 for x and so on and so on. But the easiest way to do this is go to your y-intercept and ask yourself, where is the next y value that is greater than your y-intercept? It's negative 6 and so forth. So you're going to be shading this way. You're going to be shading from the line and then above your y-intercept. A lot of you shaded below the line because you just quickly manipulated this in your mind. That's fine, but make sure you test your solution point. If you would have tested a solution point out here, I don't know, let's do you can do 1, 2, 3, 4, 5. You can test that point right there. 5, negative 1. You can test for 5, negative 1 into this expression up here, and that would be a false statement. And then you would just shade up here. Okay? So that would be 3 points. Next, elimination method. We did a WISC video. We did a couple practice problems on this, and I hope that you guys continue to practice this. Elimination is actually a little bit more efficient without substitution. You will eliminate and then substitute. So let's just jump right in. I have 13x, 4x right here. A lot of you just like to get rid of your x right away because it's first. But you know that in order to eliminate, the fastest way to eliminate is opposite signs. Luckily, we already have 3y and negative 2y. I'm just going to change both into 6y. One positive 6 and one negative 6. So I'm going to multiply the top one by 3, multiply the bottom one by 2. So this is my equation A, equation B. So equation A, the new one, not really though, it's just a multiple, is going to be 39x minus 6y is equal to 75. My new equation B, not really new, just a multiple, is going to be 8x plus 6y is equal to negative 28. Here, since I already have opposite pairs, I'm just going to add them. This goes away. Go up here real quick. 39x plus 8x is 47x is equal to 75 plus 28 is 47. I divide both sides by 47. X is 1. Again, some of you just stop right here. That's only half of it. Now that you found 1 as x, you plug it back in to one of these to find y. So just go ahead and pick one. I'm going to go ahead and do equation B, just because I did A last time. So here's equation B. You can actually technically do either of these because, again, both of these B's equations, they're the same. They're multiples of each other. So equation B is 4x plus 3y is equal to negative 14. I know that x is 1, so I'm going to take it and I'm going to put it right there. 4 times 1 plus 3y is equal to negative 14. 4 times 1 is 4 plus 3y is equal to negative 14. Again, I'm just undoing for y, solving for y. So here we have minus 4, minus 4. I get 3y is equal to negative 18. Again, some of you miss these questions not because your process is off, but just you're in a rush or you're just forgetting your number sense. Careful. Okay? Dividing both sides by 3, y is equal to negative 6. Positive divided by negative 18 divided by positive 3 is negative 6. And there's my solution point. And make sure that you also test for equation A now. Take both of these and put it into equation A, and you should get 25, and you should be good. Okay? Next, graph the inequality y is greater than x plus 2. Let's just talk about what I see right now. I see that there's a greater than symbol. So I know that that is going to be a dash or a dotted line. I also notice that y is by itself. I see an x in there. So right away, this resembles y is equal to mx plus b. Or in this case, y is greater than mx plus b. So my y-intercept is 2. Okay. And my slope is x, or 1x. So when you have a slope of 1x, or just x, that's 1 over 1. So it's going to be up 1 over 1. This is a slope of change in 1 over change in 1. 1 over 1. Going backwards, you can do negative 1, down 1. You can go negative 1, negative 1. That still gives you positive 1. So there is my line. Looks something like that. And then you need to shade. Again, go to your y-intercept. As long as it's in slope-intercept form, go to your y-intercept. Ask yourself, where's the next y value that corresponds with this symbol? The next y value that is greater than 2 is up here. So I'm just going to shade above 2. Continue my line there. Okay. Again, I gave you, that was out of 4 points. I wanted to see the y-intercept, I wanted to see the slope, I wanted to see the solid line, and then I wanted to see the shading. The systems of equations are 3 points because 1 for x, 1 for y, and then 1 for actually doing the correct step, the process. Okay, the last one is a review question. You're solving the following inequality for x. I'm not even asking you to graph it. So I'm just going to go ahead and build it. Here's x. First thing that happens is multiply by negative 2, add 3, divide by 4. So the first thing I need to do to both sides is multiply by 4. Okay, multiplying both sides by 4 over 1 is the same thing as 4 because these are fractions here. This cancels out. The numerator does not get touched yet. I'm just going to go ahead and do all the inverse of those. Now I have negative 2x plus 3 is less than or equal to 24. Next step, following my undo, minus 3 from both sides, or subtract 3. I get negative 2x is less than or equal to 21. Next, divide both sides by negative 2. I'm just following my blueprint here. Divide both sides by negative 2. And this is a trick right here. Some of you keep forgetting this. When you divide by negative or positive or multiple, when you multiply or divide by a negative integer, you have to flip your inequality sign. Negative 21 halves or 21 over negative 2 is the same thing. And there's my solution right there. Some of you might have changed it to x is greater than or equal to negative 10.5. That's all right too. I'm okay with either of those. What's incorrect is if you wrote x is less than or equal to negative 10.5, negative 21 halves. Okay? And also make sure that you guys are checking your work. If you forgot to flip your sign and you wrote something like this, go ahead and pick a number that's less than negative 10.5. I don't know, do negative 11, negative 12, negative 13, negative 20. It would take you no time to check, like, oh, if I put in negative 11, it wouldn't work for this. So I must have to flip my sign. You can do a number that is greater than negative 10.5. I would choose 0. Put in 0. 0 times negative 2 is 0, plus 3/4, plus 3 is 3. 3 divided by 4 is 0.75. 0.75 is definitely less than or equal to 6. Okay? So that's all I have for you guys today. I just want to walk you guys through the quiz again. So make sure you guys are doing the reflection form and turn it into the basket for half credit. Thanks, guys.